Okay, let us read the question. We have figure 7 shows how potential energy, so we have potential energy with symbol U, changes with displacement for a mass spring system. A system of mass spring that oscillates about equilibrium position O, and the spring constant is 2 Newton per centimeter. So we have K here. Okay, the value of K, spring constant. So the first question is to calculate the maximum displacement. Okay, so at maximum, or it is also known as amplitude. Okay, and the second question is to calculate the position when the kinetic energy and the potential energy are equal. So, which means that we want to find x, okay, position when with the condition kinetic energy is equal to potential energy. Okay, but we want to find x. Okay, and the last one is if the amplitude of the oscillation is doubled. Okay, so what will happen to the total energy? So if the amplitude is doubled, what will happen to total energy? We're solving the first question. Okay, calculate the maximum displacement as max. So we need to extract the information from the graph. So we have from the graph, we can see that our maximum value of U is equal to 3. So we can have the equation of U. So U is equal to half K as maximum squared at the condition of maximum. So our U is 3 is equal to half. So just now I've mentioned that our value of K is equal to, is not in SI units, so it is equal to 2 Newton per centimeter. So make sure we change our value of K into SI unit first to make sure everything is smooth in solving this question. So 2 per centimeter is equal to 2 over 2 Newton over cm. So converting cm into meter is 1 times minus 2. So it is equal to 2 times 10 to the power of 2 per meter. Okay, so finally you can have your U is equal to 3, K is 2 times 10 to the power of 2 as maximum squared. Your final value of X maximum will be 0.173 meter. So the next question, that is question number 2. So just now we have read the question. We want to get X position when our kinetic energy is equal to potential energy. Okay, so we substitute the equation for kinetic energy is equal to half m omega squared a squared minus x squared, which is equal to half m omega squared x squared. Okay, so just now we use k here, right? So it is actually the same. So m omega squared is equal to k. So we can compare the left side and the right side of the equation. Half m omega squared is equals. So we can cancel it out. So what is left here is a squared is minus x squared equal to x squared. A squared is equal to 2x squared. Okay, so to get x, okay, we want to find position x. So x is equal to a squared over 2 square root, which is equal to a over square root 2. We have got a from the first question, so it is 0.173 over square root 2. So you'll get your x is equal to 0.12 meter. Okay, next for question number 3. Okay, so we give the question gives us a condition where our amplitude, our new amplitude is doubled. So it is equal to 2a original A. So what will happen to the energy? So bear in mind our original energy is equal to half K A squared. This is the equation for energy. So if our A is doubled, which means that we are going to have our new total energy. So it's equal to half K 2A squared. Okay, so which is equal to E half K A squared times 4. Half K A squared here is equal to E, meaning that this equation for E. So what will happen to the total energy? The answer is the total energy is equal to 4 times the original E.